Hi everyone, welcome to Code Type Management. So, in the earlier lecture, we have covered the transactional annotation part one. So there we have covered like how the transaction lifecycle is working, then how the transactions begins, how commit and rollback works. Okay, so now in this part two, we will mainly discuss about the transaction manager hierarchy, and then we will describe like how the programmatic transaction management works, how the declarative transaction management also works. Okay, so these are the topics. So let's discuss. First of all, the hierarchy is like that. Here you can see the transaction manager interface is there, right? So it is the root. So in part one, we learned how the transactional annotation uses the AOP to magically protect our database from the risk conditions. But how does Spring actually talk to the database to execute those commits and rollbacks? And what if you don't want AOP to manage your transaction, but want to do it yourself manually? So today we are just popping the hood on Spring's transaction management. Okay, so that's the agenda actually. So briefly, we will state that you will going to see like how the manager hierarchy works, how the Spring Boot auto configures it, and the two main ways to manage the transactions. One is declarative versus programmatic. So here the boss interface is like transaction manager, and then it actually extends the interface platform transaction manager. So that is the core interface at the top of the hierarchy. Then Spring Framework doesn't actually interact with the database directly to manage the transactions. It uses an abstraction called the abstract platform transaction manager. That's the actual abstract class. So that actually I have told you that interface extends the platform transaction manager, and that basically implements this abstraction platform transaction manager. And we have many types of concrete classes on top of that. But the thing is, this platform transaction manager has the three main core methods. One is get transaction, commit, and another is rollback. And now the abstract class, this abstract platform transaction manager basically provides default implementation of the these methods actually: get transaction, commit, and rollback. Okay, and now we will have the concrete classes. The one is data source transaction manager, then Hibernate transaction manager, JPA transaction manager, ZTA transaction manager. Clear? So these are the main concrete classes. Now this data source transaction manager also has the JDBC transaction manager. So that is basically works as the Java database connectivity. And this JPA transaction manager, mainly the Java persistence API, ZTA transaction manager, also the Java persistence, Java transaction, not the persistence, Java transaction API, Java transaction API, so ZTA. Okay, so now this all manages the local transactions from this data source transaction manager to Hibernate transaction manager and JPA transaction manager. This all manage the local transaction, local transaction. And this JTA transaction manager actually manage the distributed transactions, distributed transactions. Clear? So now we have like the integration. So because it's an interface, this platform transaction management manager, so it needs an implementation which I have covered. That implementation covered by this abstract class. And this is where Spring Boot actually incredibly works smart. So it looks at the dependencies in your POM XML, and it will choose the right implementation for you. So like you're using, if you will use the plain JDBC, so Spring Boot automatically injects the data source transaction manager. Okay. If you want to use the Spring Data JPA or Hibernate, then Spring Boot injects the JPA Transaction Manager or the Hibernate Transaction Manager. So both of these implement the Platform Transaction Manager. So your code stays the same regardless of the underlying technology. If you will use the direct JDBC, it will work. If you will use the Hibernate or JPA, all things will be work. So here concrete implementations also have added here. The data source transaction manager used with the JDBC type is local. JDBC transaction manager also used with JDBC type is local. Hibernate transaction manager used with the Hibernate type is local. JPA transaction manager used with the JPA type is local, and JTA transaction manager used with JTA. Java transaction uh, API. So it is here I have mentioned this is the distributed transactions. So type is distributed. All are local. This JDBC data source, Hibernate, JPA, all are local transactions, and this JTA is the distributed transactions. So now transaction management types. There are two types of transactions. So declarative transaction management and programmatic transaction management. So what does this declarative transaction management? So in earlier lectures, so in part one, I have discussed about the main transaction management with the declarative transactions. So it actually use the transactional annotations. It managed by Spring automatically, and it is clean and recommended. Okay, so here we don't have any hand, only Spring manage that one. So declarative means you will tell the Spring what you want to do, not how to do. Okay, so you simply declare your intentions using the transactional annotations. Okay, so that's the point. Here you will specifically you will use the transactional annotations. You will declare to Spring like what you need to do. Okay, and Spring will manage all those things. So what is the pros on that? So it's very clean code, zero boilerplate. You need not to do anything. Keeps business logic completely separate from your infrastructure logic. And cons is like it applies to the whole method. If you have suppose 100 line of method, but only need 5 lines to be transactional, you might be holding on to database locks longer than necessary. Okay, next is programmatic transaction management. So what does programmatic means? So writing the exact code to start, commit, and roll back the transaction manually. You will have the control on that. Okay, approach one is like you can do via the raw platform transaction manager. So so this is the lowest level of approach. So we have to define the transaction rules manually and grab the status and wrap the everything in an ugly try-catch block. Here you can see your transfer service is mentioned, and then your suppose platform transaction manager, that's injection you are doing, then your transfer service that is there. Transfer service. This constructor is mentioned here, and then you have the method like transfer raw. Okay, and inside the try catch block only you have the methods like transaction manager dot commit. If it all will be okay, like your debit logic, credit logic, all things will be okay, then commit will be done. Otherwise, if any exceptions, then rollback will be happen. Okay, now The second approach is through your transaction template. Okay, so the problem with the approach one is it's very messy and prone to errors like forgetting to call the rollback. Okay, in the cache block. So the solution is transaction template. So transaction, what does it? So Spring recognized that the first approach was boilerplate heavy, so they created the transactional template and it handles the try catch commit rollback logic for you, but still lets you execute transactions programmatically on specific blocks of code. So you have the transfer service in the same way. Here you have this new transactional template. Now in this transactional template, you are overriding suppose this do in transaction without result, okay, status. Now inside this try block you have the debit from this account and credit from this one, okay. And next is catch is here set rollback only. It is optional manual trigger for rollback, but other than that nothing is there. You don't have any, you don't need to do any commit call, you don't need to do any rollback call, right? So here all things are manageable. So here we are just we use the declarative transactional 95% of the time for clean code, use programmatic transactional template only when you need some surgical precision over exactly when a transaction starts and ends within a massive method. So here you can see that only we have the transfer service class, okay, and here the transaction template, okay, we have injected this transaction template, okay. And then inside this transfer service method you will have the things, this transfer with template, you have the method inside that you are executing this transaction template, this one here. We have the this method, right? This transaction callback without result, okay. It's clean, right? And you also have the handle on it, okay. So we have converted the platform transaction manager, how the Spring Boot auto configures it use based on the JPA versus JDBC and the difference between the declarative and programmatic, okay. So just do like, share, subscribe to motivate me, okay. Next we in the next lecture we will discuss about the propagation mainly, okay. So if you have any confusions on this transaction template, how it is working, how the things work with the transactional annotations, how the declarative works, how the programmatic transaction management works, you can comment below. Okay, we will discuss again. No problem. Okay, thanks everyone for watching.